Hello, today video will discuss some more methods related to IPC. Here the first one, FIFOs, as name indicated, first in first out, are sometimes called named pipes. The reason why it has been called named pipes, because this mechanism we can use between the two processes. Those processes are belonging to different ancestors. That means the process A is belonging to the one parent relationship and process B is belonging to another parent relationship. Now we can club or we can interact by using IPC here, by using a FIFOs. The API we are using for this one is MK FIFO. I think already we discussed this one. Here it is containing the two argument path name. It is nothing but in which location you wanted to create the FIFO file and in which mode, like read or write mode. Here unsuccessful condition, it is returning the 0 values, and on failure condition it is returning the 1 here. Once we have used the MK FIFO to create a FIFO file, we open it using for open. That means by using normal API only we are using to open the FIFO file. There is no specific APIs here. There is two things happen in the normal case, that is nothing but non-doc. I think already we discussed about as part of the open API, and open for read only blocks until some other process opens the FIFO for writing. Similarly, an open for write only blocks until the same process opens the FIFO for reading here. So this indicates here, if suppose I could not specify the O non-block flag, then we are open the FIFO file. Read purpose, it will be blocked until some other process opens the FIFO for writing here. Similarly, an open opens for write only blocks until some other process opens the for reading. If this is with respect to non-block flag is not specified. If O non-block flag is specified, then it returns immediately, but an open API for write only returns 1 with error set to ENXIO if no process has the FIFO open for reading here. So these are the two conditions. There are two uses of the FIFO. One is FIFOs are used by shell command to pass the data one cell pipeline to another without creating the intermediate temporary files. FIFOs are used as a reduce points in client-server applications to pass the data between client and server. We discuss one by one here. The first one, FIFOs are used by shell commands to pass the data from one cell pipeline to another without creating intermediate temporary files. You take this program, this diagram representation. Here the input file is connected to the program 1, but the program 1 wanted to send the data to program 3 and program 2 without creating the intermediate files. So usually it is only possible by using intermediate temporary files. So is it any solution? Yes, it is a solution is there, but we can use the FIFO here. We'll see that how exactly that has been used. This is the diagram what we can explaining here. Input program 1 and T is I'll explain this one. Here the FIFO, it is connected to program 3. Okay, just we can find it with FIFO and the Unix program. We can accomplish this process without using temporary file. The T program copies its standard input to both its standard output and to the file name on its command line. That is nothing but this command, what it does, whatever the output generated by the program 1 will be forwarding to FIFO and as well as writing to FIFO and as well as standard output, standard console here. We can create this FIFO and then we start the program 3 in the background. Reading from FIFO, we can start program 1 and use T to send its input both FIFO and program 2. Just we can make the arrangement what I given. MK FIFO 1, we created this FIFO file. We are using along with the program 3. Yes, just we can find it here. And program 1, nothing but this one is connected to in file, that is nothing but the input file here. Okay, that is, it is taking the input here. The file that indicates that it is the external user who connected the FIFO here. So what we need to understand with respect to this concept is that whenever we want to transfer the command execution output from one file to one program to another program, we can do by using FIFO rather than creating the temporary files. FIFOs are used to send the data between client and server. If we had a server that is contacted by numerous clients, each client can write its request to a well-known FIFO that the server creates. Since there are multiple writers for the FIFO, okay, the request sent by the client to the server need to be less than that nothing but this is the one example. There is only one server which is connected by the multiple clients, so different client is sending the different request. Okay, that one is managed by using the FIFO. Second point, this prevents any interleaving of client rights. The problem using FIFO for this type of client server is how to send the replies back from server to client. Nothing but the one problem is solved, that is the client can write the request to server by using FIFO. Again, the problem with respect to this one is that how the server can communicate to individual client and it can send the reply here. A single FIFO cannot be used, as the client would never know when to read their response versus responses for other clients. One solution for each client to send its process ID with a request. The server can create a unique FIFO for each client using path name based on the client process ID. So that is nothing but whenever the client is sending the request to server, it should send the request along with its PID. Then the server can easily identify which client is currently sending this request. Then based on that ID, it can create its one more FIFO. From that FIFO, it can communicate the client once again. Okay. The server also must cache pipe signal, since it is possible for client to send a request and terminate before reading its response, leaving the client specific FIFO with one writer and no reader here. Okay. This is the diagrammatic representation. I'll explain here. As I told, multiple clients are connected to server by using well-known FIFO. They are sending their individual request, and from this FIFO, the server is reading the request. But the problem is that how the server can reply to individual clients, because each client is having its own request. So what is the solution for this? So there is a solution has been provided here. Client is writing its individual request by using the FIFO mechanism, and the same thing is read by the server from server to client here. See that? Okay, it will write it the replies. The same reply has been read by the client. So one thing what we need to understand is that the server is establishing client specific FIFOs by using FIFO method. Okay, this is the one more use of the FIFO here. Then XSI IPC, nothing but it is a message queues, semaphores and shared memory concept, what we can call as a XSI IPC here. They are maintaining the one unique structure. It is referred by non-negative integer. That is what I can call as an identifier. The identifier is the internal name for the IPC object. The cooperating process need an external naming scheme to be able to render use using the same IPC object. For this purpose, an IPC object is associated with the key that acts as an external name. Whenever the IPC structure is being created, key must be specified. So that is nothing but whenever we are establishing the IPC, it is with respect to a particular IPC object. So that should connected with the one key value here. Okay. The data type of this key is a primitive system data type, which is often defined as a long integer in the header file. There are various ways for client and server they can communicate at the same IPC structure. So for that concern, we are allowing the 3 points. A server can create a new IPC structure by specifying key IPC private and store the return identifier somewhere for the client to obtain. The key IPC private guarantees that the server creates a new IPC structure. The disadvantage of this technique is that the file system operations are required for the server to write the integer identifier to a file and then for the clients to retrieve this identifier later. That is nothing but what we are doing. There is a one structure named as IPC private that the server creates the new IP structure. Okay. So in this structure we can find a unique identifier that later on the client can refer. The client and server can agree on a key by defining the key in common header. That means the both client and the server, they are having the kind of agreement. That means what is the structure we need to use for the inter-process communication. According to that only they are using the IPC methods. Third one, the client and server can agree on path name and the project ID. The project ID is a character value between 0 to 255 and we are calling the F2 function to convert these two values into a key. This key is then used in as usual like second step. So this is about the structure what we are using in XSI IPC structure. Okay. Just we can make the observation, it is having the different fields. UID, that is nothing but effective user ID. GID, that is the owner effective group ID. CUID, creators effective user ID. CGID, creator effective group ID. Mode T, that is the access modes like read and write. Okay. So that way we are having the one structure related to a permission structure. Then what is the advantage with respect to this XSI IPC here? The fundamental problem with XSI IPC is that IPC structure are system wide and do not have a reference count. For example, if we create the message queues, place some messages on the queue and then terminate, the message queue and its contents are not deleted. They remain in the system until specifically read or deleted by some process calling the message receive and message control by someone executing the IPC remove command. Okay. Next, one more problem with respect to this one disadvantage is that IP structure not known by the names in the file system means does not have any specific naming conventions. We cannot access them and modify their properties with the function. Almost a dozen of new system calls like message get, semaphore, semmat and so on. We are added to the kernel to support these IPC objects we cannot see the IPC object with ls command, nothing but we can't list any info